We're going to talk about a couple of these things we've already talked about. So perpendicular bisectors and angle bisectors. We're just going to add some properties that we have not already talked about, but let you solve some problems using the properties that we have not discussed so far for perpendicular bisectors and angle bisectors. Okay, these can be very tricky in the diagrams. All right, so this diagram, A to B, is just a segment, and C to D is going to be the perpendicular bisector. So I just copied like the definition from earlier in the semester. It can be a segment. In this picture, it's a line. It could be a segment, a line, or a ray that cuts a segment into two congruent segments and then specifically at a 90-degree angle. So you're going to see a right angle mark in a lot of these diagrams today. So this diagram specifically, CD, that line, is going to be the perpendicular bisector of AB, the segment. Okay. Now, because it's a perpendicular bisector of the segment, it's going to give you some special properties, which I'm going to write down in this perpendicular bisector here and here, and I got an illustration to kind of show you how this works. Okay, so this is going to say if a point, so I'm just going to put the word point, is on the perpendicular, I'm just going to use that perpendicular symbol, is on the perpendicular bisector of a segment, then that point is going to be what we call equidistant. And that's just a fancy math word for equal distance. It's going to be equidistant from the end points of the segment. Okay, so I'm going to draw on this picture just a little bit here. So basically, like if I go back to this drawing, right, C is on that pink line. What it's trying to say to you is if I draw and connect A to C and C to B, if I connect those segments that I just drew in there, AC and BC, those segments would be congruent to each other is what's going to happen there. So any point on that line, if you just take it and connect it to the endpoints of the segment, those lengths would be the same. So just in the diagram here underneath, they are just showing you, again, this is just a little different picture. So the segment AB and P to M here would be your perpendicular bisector. So then right next to it, it's just trying to show you that P, a point on that line, is going to be the same distance from the two endpoints. You could literally draw, like I could, let me go, I'm going to come to this drawing, right? Let's just say I drew a random point. A to that point, B to that point, they would be the same length. Not necessarily, it's not going to be the same as P to that because it's a different point, but you could literally draw, like I could draw a point up here. This distance, they would be the same length. As long as the point is on the perpendicular bisector, if you draw a segment connecting that point to the two endpoints, then they're going to have, that one looks really bad as I'm looking at it, sorry, but the distances should be the same. Okay, the converse is just going to go backwards from this. So it's going to say if a point is equidistant, just equal distance, from the endpoints of a segment, then it has to be on the perpendicular bisector of that segment. So if you don't know it's a perpendicular bisector, if you have on either side a point that's equidistant to the endpoints, it has to be on it. And we'll do some constructions with this a little bit later in this unit. But like in the picture here, this is showing you P is equidistant to the two endpoints of the segment AB here. So then what they're saying over here, if I drew a line that connected at a 90-degree angle where that point P is, so a perpendicular line through P that would go through A and B, it would be on the perpendicular bisector. So then in this diagram, P to M would be the perpendicular bisector of that segment AB. It just means it cuts it in half at a 90-degree angle. Okay, now the actual problems you guys are going to do are going to be like what I have in example 1 down here. And I promise this is not, don't overthink this, okay? Don't overthink this. It's not bad. That's why I said I don't think you guys will need a calculator today. If I've got AC here, right? I'm just kind of highlighting that. That runs into the segment from B to D at a 90-degree angle. And then also on either side where that intersects at point E, so D to E is marked as being congruent to B to E. So what that means, this means AC is the perpendicular bisector of BD. Okay, now let me ask you a quick question while you're looking at that. Is BD the perpendicular bisector of AC? Does it work the other way around there? Is BD the perpendicular bisector of AC? So this is not. I know a couple people are shaking their head. Okay, like A to E in that diagram, you don't have to write this down, but A to E is not congruent to EC in that diagram. You guys can see EC is a little bit longer there. So they don't bisect each other. Only AC cuts DEB, or DB into 2 equal pieces. It doesn't work the other way. Okay, so keep that in mind. So any point on this line, I colored on my paper in green, any point on this line, including A, would be one of those points, is equidistant to the 2 endpoints of that segment from D to B. So my first question just says, tell me the length of AB. So what would you tell me? 15, done. Don't think about it too hard. So A, the endpoints are D and B, equidistant. That's going to work that way. Now, if you look like C on the perpendicular bisector of DB, so C to endpoint, C to the other endpoint, same distance. If C to B is 18, C to D is also 18. Don't think about it too hard. Anybody have any question at the moment? Okay. So I got one diagram just at the bottom. Now this is a little bit trickier with the algebra here. So P to R, that segment is being bisected at a perpendicular, because I see the 90-degree angle. I'm just going to extend that a little bit. S to Q is the perpendicular bisector of P to R. All right, so any point on that line, including Q here, you guys can see S to P and S to R. Those are marked as being congruent, so that's a point on the line equidistant to those endpoints. Q to R and Q to P, these two, I'm going to mark with a double mark because I already have a single mark in the picture, but those two segments have to be equal to each other. All right, so all I got to do to solve this question, this says find me the length of QR here. Okay, so how would you find the length of QR? Like, what would you do with this problem? What would you do with them?
I don't know, make it to that, this, that, from that.
Yeah.
So we have to make sure that any is negative so that we probably resolve it.
Not necessarily. It's possible n could be a negative number. I don't think it is here. Our segment should not be a negative length. So if I've got, these two have to be equal, right? So how would I solve this equation? Like, what would you do? Go ahead.
Mm-hmm.
Yeah.
I feel like if I had to solve it, I have to try maybe, first off, I'll really do something to end, maybe 5 from the 3 with -2, and then
Okay.
add 1 to the -7, make it -6, and then divide both by 2.
Perfect, perfect. Okay, so he's subtracting 5n from both sides. So 3 minus 5 would give you -2n's minus 1. And then he just did this in the same step. I'm going to do it separate, but add 1. So we get -2n is equal to -6. And so then there, the negatives are canceling out, and n is going to be 3. But be careful here, because that's not the answer to my question. The question says find the length excuse me, of QR, how would I find the length of QR? Go ahead.
You take N and plug it into what the equation what you are.
There you go.
It must be,
You got 8? Yeah, okay, so we would just do 5 times 3 minus 7, that's 15 minus 7, which is going to give you 8. So this would be the actual answer to the question. We got to find N to get there, but to plug it back in to get the segment length is what you got to do to answer the question. Okay. Now, we're going to switch and talk about angle bisectors. And there's a third page to the notes. I'm sorry, it's just kind of spaced out. It's not going to take longer than it normally does. Okay, now, you're not going to have to write anything here. I'm just going to color you a little bit of a picture. All right, so I have an angle here, LKJ. And I have an angle bisector here, which is the ray from K to M. Okay, so an angle bisector just cuts an angle into 2 equal angles. And it says that right underneath the definition, KM bisects that angle LKJ. And I got to use all 3 letters there because I got too many lines going into the vertex K there, so I've got to be more specific when I describe my angles. And then it says measure of angle LKM, so that would be specifically this one here, is going to be equal to the measure of JKM. So those 2 angles have the same measurement. Like I don't have a number here. I don't know. What does that look like? Let's say this was 40 degrees. This would automatically, I'm just making that up just to give you an example. But both of those angles would have the same measure. They do have the little curve really close to the letter K to mark that in the diagram. But just to let you know, that just means they have the same measure if you've got an angle bisector. Okay. The other thing we're going to talk about real quick, because this is going to go with a property of the angle bisector, is how to find the distance from a point to a line. Okay, now I'm going to abbreviate here, but this says the distance from a point to a line is the length of the perpendicular, is what I was going to have you guys write there. I'm just going to write the symbol. So it's the length of the perpendicular segment from the point to the line. And just to show you just a general picture here, I have a line labeled with a cursive L here. And just to show you how you would find the distance from a point to the line, I have 2 different points. One is an A, one is a B. The distance from point A to that line would just be, you just have to go straight 90-degree angle. That segment would represent the distance between that line and that point. Now, why am I making a deal about this? Like, don't draw this on your picture, but couldn't I could connect A with that line. I could do like a diagonal line, right? I could come over here, maybe this. So to define the actual distance, that's why, because we could draw a bunch of different ways to connect that point to that line. The reason we define it this way is so it's consistent. So it's a perpendicular line from that point to the line. For point B, this is kind of underneath the line. Same thing. If I just draw a straight perpendicular to the line from the point, that would represent the distance. Okay? So you're going to see a bunch of right angles in these next couple things when I show you guys the angle bisector theorem. Sure. ABT. I like that. All right. If the point, or if you have a point, is on the, I'm going to write angle bisector. I'm just going to abbreviate the word angle with that symbol. If a point is on the angle bisector of an angle, then the point is equidistant. So again, that's just meaning equal distance from the sides, which most of the time when you're talking about an angle, the 2 sides are formed by rays that run into a vertex. So it's going to be equidistant from the 2 sides of the angle. And I'm just using that angle symbol to abbreviate, frankly, because I'm being lazy. Okay, now, here's the deal. If I have an angle, here I have CAB. You're not going to have to measure anything. Don't worry about that. They put a little ruler in here, though, to show this is the angle bisector. The distance here from D to that side of the angle and from D to the other side of the angle between those 2 rays, those distances, like this guy right here and this guy right here, those distances would be the same, is what it's trying to mark. So here's what this says. Here's your angle bisector, and this picture is Q to S. And you have to have perpendicular to represent the two lengths from the point being S here, to the side of the angle. So it'd be P and R. So they're saying if that's on for sure the angle bisector, then the distance from that point, which is S, to the two sides of the angle on either side there, that's going to be exactly the same. So I don't know, let me just make up a number. Like let's say, I don't know, if this is 4, then this would be 4. Something like that. Like the two segment lengths would be exactly the same. All right, the converse is just going to flip that around. It has a little bit more words to it here. This says if a point is in the interior of an angle, I'm just going to sketch a little tiny picture here. Here's an angle. The interior is in between the two sides of the angle. So if a point is somewhere in between the two rays that form the angle, that's the interior. So if a point in the interior of an angle is equidistant, again, it's the word of the day. It is. If it's equidistant from the sides of an angle, then the point is going to be on the angle bisector. So if you can see in a diagram, they give you that the segments are the same between a point and the sides of an angle. So what's going on here? Here's my angle. You'll notice there's no angle bisector in that diagram, but it's showing you this segment and this segment are the same. That means if I would go ahead, and you could draw this in a picture if you wanted to, it's pretty easy to do. You would just connect the vertex to that point. That would form the angle bisector of that angle. So if you know a point is equidistant from the side, it's got to be on the angle bisector. Now, the actual questions that you guys are going to see are going to be on the last page here, real quick. And so you got to see the right angles in these diagrams to make sure those distances are being marked properly. But what I've got in example 2, we're just going to use this first picture for this first question, and then all the other questions are going to go with the diagram that's a little bit farther down the page. Okay, now, I know that I have an angle bisector here, right? Because in the diagram, I have those little curves on the angles. So on either side of that, those angles are being marked equal. So what that's going to be implying to me, any point on that ray that I just highlighted with my lovely green marker, if I have a point there, I'm going to look at F specifically, those two distances that I've got marked with my pink now, as long as it intersects at a 90-degree angle with the side of the angle, then these two segments have to be equal to each other. So F to D, F to B have to be equal. So literally all you got to do, we're just going to set these equal. So 6x plus 3 has to be equal 4x plus 9. However you want to solve it, if it's me, I'm going to try to keep my variable positive here real quick. So I would subtract 4x from both sides. Subtracting that from 6x is going to give you 2 x's. Plus 3 equals 9. I'm just going to move the 3 real quick to get x by itself. So I get 2x is equal to 6. X would be 3 then, but just make sure you read the question real carefully. So the question says find the length of FB. So most of these you might just have to plug that back in real quick. So F to B is that 6x plus 3, but I know x is 3, so I can just plug that in real quick. So it would just be 18 plus 3, so it would be 21. That would be my actual answer to the question. All right, and then the rest of these questions are going to go with this diagram that I have toward the bottom of the page. We're going to find a couple of things here. Let me see if I can scooch this up here. All right, could you just tell me the length of the segment from L to F?
L to F.
And I'm just realizing that I guess it doesn't connect to F. I just realized that. I mean that segment right there that I just highlighted. I got to rewrite this real quick. What would that segment length be? 27. Done. That's it. These two are the same. So any point If it's equidistant from the two sides, which I have that marked on the diagram then, so this is to me 27. So if that's equidistant from the two sides, both sides 27, that means that LH has to be the angle bisector. So that's going to be the second part of the question. Or it says HL, sorry. This is going to be the angle bisector. And the reason I know that is L is equidistant from the sides of the angle. Both marked as being 27 there. All right, so it has to be on the angle bisector. So if it has to be on the angle bisector, that is going to force this angle here and this angle here. So it's going to force angle KHL to be congruent to angle FHL because it's on the angle bisector. So if I want to find y, we just have to set those two expressions. I have 6y degrees here is equal to 4y plus 18. We're just going to set them equal. Okay, now I'm just going to do this real quick. Subtract 4y. So I'd get 2y is equal to 18. And if I divide that there, y is going to be 9. And that's what the question says. Find me the value of y. Okay, then it says find me the measure of the two angles, KHL and FHL. Now, they should both be the same, right? So just plug it in once. So if I do KHL, that was the 6y. So it's just 6 times 9 be 54 degrees. You can plug it into the other one. 4 times 9 is 36 plus 18. Give you the same thing, but they should both be 54 since that's an angle bisector. Okay, now, here's the trickiest part to this question. And I might redraw the diagram just a second here. It says, find me the measure of KLF. So up in the diagram, that is like this entire angle here. So I'm just going to come down so I can get this on the page at the same time, but I'm just going to try my best to kind of reconstruct this. This does not look good already, sorry. All right, so I have these two right angles, yes. I have this angle bisector here. And the 27, I'm not going to put, this is not F, sorry. I'm not going to put this into the picture right now. All right. I know that this angle here is 54, and I know this angle here is 54. I want to find this whole angle here. Anybody know how you might do that?
I might.
What would you do?
So, a triangle must, inside the angle must have one A both sides of it. So you always have a 9 and 4. So that's 1.4, so take 1 A. Might have 1.4 and get 36, which must be the answer.
Okay, now, hang on a second. You're totally on the right track. This angle here would be 36, right? Because he's saying if we have a triangle, if I use that angle bisector, got a triangle here, this would be 36. What would be the measure of the angle right next to it? Also 36. So that entire thing there together, you just have to do 36 and 36, just angle addition. Those two angles form that entire angle I'm trying to find. So that'd be 72. Okay, is anybody having a question? Okay, I'm going to let you guys go ahead. The homework assignment, I think I mentioned this, maybe not. I put it on Canvas and stuff. But on the homework,